Now let us take a look at self-exercise 2.3 in your textbook. Okay, so this section deals with rate of change under the topic on differentiation. So let us go through the question first. Question number 5, yeah? We are looking at question number 5. Chandran walks at a rate of 3.5 meters per second away from a lamppost one night as shown in the diagram on the right. So take a look at the diagram on the right. You are given the person here. So the person is name is Chandran is walking away from a lamppost. There's a lamppost over here. So he's walking away. Okay, walking away in this direction. So walking away at the rate of 3.5 meters per second. Okay, so that is the rate at which is walking away from the lamppost. The heights of Chandran and the lamppost are 1.8 meters and 6 meters respectively. So you are given the height of the person and the height of the lamppost. Find the rate of change of Chandran's shadow. Okay, you can see over here. So the person here will cast a shadow. Light is over this side, and then there will be a shadow on the right hand side here. So when Chandran moves away from the lamppost, his shadow will also change in length. It will become longer and longer. So you're asked to find the rate of change of Chandran's shadow. In the second part, part B, you are asked to find what is the rate of change of the moving tip of the shadow. Moving tip refers to the end of the shadow here. So the tip of the shadow is also moving away. And you are asked to find at what rate is the tip of the shadow moving. So before we solve this problem, let us revise a bit of the theory related to this problem. So I'll put the theory in square bracket here. So if you are given x and y as two variables that are related by a function, if x and y are related, okay, x and y are related by the function y is equal to f of x. And x is changing with respect to time. Okay, and x changes with time at the rate of dx by dt. Okay, so because x and y are related and x is changing with time at the rate of dx by dt, therefore y will also change. Therefore, rate of change of y is given by dy by dt. It's given by dy by dt. And this value is given by dy by dx multiplied by dx by dt. So we're actually making use of chain rule. We can find the dy by dx value from the function relating x and y, and this value is known, and the rate at which x is changing is also given. Therefore, we can find dy by dt. So this is the concept we're going to use in this problem. Okay, so in order to solve this problem, I'm going to copy this down again so you can see more clearly. And we're going to use the above concept to solve this problem. So we need to find out in the question, where is x and y? So you notice that in this question, there's no x and y given to you. But we know that we are asked to find the rate of change of Chandran's shadow. So where is Chandran's shadow? Chandran's shadow is over here. Therefore, the length of the shadow, we call this length y. We give this distance y. And then the position of Chandran from the lamppost, this distance becomes x. Okay, so the length of the shadow is y, and then the position of the position of Chandran is x. So we are asked to find the rate at which y is changing. So we need to relate x and y. Okay, so we can relate x and y by using the concept of similar triangle. You can see there's one big triangle here. This triangle is similar to the smaller triangle over there because they're sharing a common angle. So if you take 6 divided by x plus y, this will be equal to 1.8 divided by y. Okay? So that is how we solve this problem. So in part A, 6 divided by x plus y will be equal to 1.8 divided by y. Okay, so we can cross multiply this, so we will get 6y is equal to 1.8x plus 1.8y. So if you bring the y to the left hand side, 6 minus 1.8 will give you 4.2 y. On the right hand side, we have 1.8x. Therefore, y is equal to 1.8x divided by 4.2. So this will give you 3 over 7x. And we can find dy by dx. We have to find what is dy by dx. From here, dy by dx will be given by 3 over 7. Okay, because this is a very simple function, so you'll get 3 over 7. Therefore, dy by dt will be equal to dy by dx multiplied by dx by dt. And dy by dx is equal to 3 over 7, whereas dx by dt is given in the question. Okay, because this distance is x, the person is moving away, so x is actually changing. So x is changing at a rate of 3.5 meters per second. So this will be multiplied by 3.5. So you will get 1.5 meters per second. So this is the answer for the first part. This is the rate at which the length of the shadow is changing. In part B, you're asked to find the rate of change of the moving tip. So when you look at the moving tip over here, the tip is located at a distance given by x plus y. Therefore, you're asked to find at what rate x plus y is changing. That will be for part B. So part B, we have to find what is the rate at which x plus y is changing. So this is given by dx by dt plus dy by dt. So this is equal to dx by dt is given in the question, which is 3.5 meter per second. Dy by dt we just calculated earlier, this is 1.5. So this will give you 5 meters per second.